Hello, my name is Justin,
Hi, I'm Azura.
and we are from the Arduino team. So for my part in this project, I focused mainly on the motion systems. So what we did was that we implemented closed-loop control with the encoders as feedback in order to get the robot to move straight. However, we realized that there are also other factors that we control, so things like wheel slip. We couldn't fully account for them, so what we decided to do was to shift our focus to aligning to the walls as often as possible. So we made so that infrared sensors were aligned to a specific distance away from the walls as and when we could.
For my part, I mainly worked on the infrared sensors of the robot. The sensors played an important role in the whole system as they were used to detect obstacles and also for alignment to ensure that the robot does not stay off course in the maze. The major challenge when dealing with the sensors was the noise at far distances. The main issue was the placement of the sensors on the robot, and we had to experiment with different positions to maximize the range and accuracy. We also soldered capacitors on the sensors to filter out the electrical noise from signal.
Hi, I'm Chukwang.
I'm Sheng Yong.
We are
with
the
the
Alpha
IT.
team. I was in charge of computer vision.
And I was in charge of the communications for all the devices in the robotics.
So for computer vision, it involved training the models for image detection, and I went through multiple models like faster RCNN, but we eventually decided to settle on YOLO V5, which is a convolutional neural network.
As for the communication, it mainly involves having to have the different devices communicate with each other at the same time. And we used JavaScript to do that because of JavaScript's innate ability for synchronous nature.
One of the biggest challenges that I faced during computer vision was mainly the accuracy of the image detection. So in order to help prevent that, I performed hyperparameter evolution to optimize the training of the images.
One of the main challenges for the Raspberry Pi's communications was having to coordinate the timings for testing different devices in the network.
Hi, I'm Kelly.
I'm Manjun, you can call me Jay.
I'm Yang Feng, and we are the Algo team.
Let's talk a little bit about the structure of our code. We've divided our code into several packages to increase maintainability and reduce dependencies. We have an agent component that handles all of the thinking. We have several algorithm components that handle the exact next cell to move to. And we've got an agent interface that handles the coordination between the RPi and the algorithms.
For fastest path, our team implemented the A-star algorithm, find the fastest path to travel from the start zone to the go zone. The algorithm calculates the heuristic cost and the historical cost. So the robot will prioritize the cells to travel if the cells have lower predicted and existing costs combined.
For image recognition, our team used a combination of the right wall hugging algorithm and our fastest path algorithm. The robot begins by hugging the right wall in order to explore the surfaces of all the obstacles attached to the walls. Once it has returned to its initial position, it uses the fastest path algorithm to navigate towards the nearest island with unexplored surfaces. One main challenge that we face for image recognition is that phantom blocks can cause our robot to be stuck in a loop while it is doing right wall hugging. Our solution is to implement a check for loops and instruct the robot to move in the opposite direction when it has reached the starting point of that loop.
3 algorithms are used for exploration. First, the robot makes a loop of the arena by following the left wall. Then it explores the center cells by going to the nearest unexplored cell. Finally, some cells are remaining which are dangerous because they're next to obstacles. The robots will navigate nearby these cells instead of on them and explore them that way. A challenge for exploration was the inaccuracies in sensor data. We would have false positives and false negatives while exploring obstacles. Our solution was to implement a bimodal counter. This allows us to take into consideration multiple observations, and also the distance of the observation made is also taken into account.
Hello everyone, I am Devesh and I worked on developing the Android application for MDP Group 13. The Android application can be divided into 2 major parts, one for displaying the arena and the robot position, and the second one for establishing the Bluetooth connection with the Raspberry Pi, which gives us command and updates of where the robot is in the maze. The cool feature of our application is moving the robot through tilt and gestures. You can navigate the robot like playing a game wherein you can tilt it and the robot will move. One another cool feature about our application is giving the start and end commands to the robot through voice recognition, like this. The main challenges faced by me was getting to think and implementing the extra features in our application like the tilting and moving the robot through gestures and even the voice recognition, which were out of our scope.
Clicking on the Bluetooth icon will allow the app to connect to the RPi. We use the config 1 button to send ping message to Arduino and Algo to check the connection between the 3 devices. While exploring, at each time step, we update the Android application based on the map details received from algorithms through Bluetooth chat as seen at the bottom of the screen.